Thank you so much, everyone, for joining us today. I have here with me Shane Michael Fox, our CEO of Link3D. My name is Janet. I'm the Chief Operations Officer at Link3D, and we're really excited to have you guys join us to learn more about how we're currently working with folks in the OEM space and service bureau space that are looking to drive operational efficiency for additive manufacturing, production planning, and scheduling. So over the next months, we are going to be launching additive manufacturing execution system webinars to dive deep into how organizations are implementing their strategies and sharing this know-how so you too could take this back and see how you could introduce new ways to improve your internal operations. Perfect. So if you have any questions, feel free to leave it in our Q&A box, leave it in our chat box. We would love to answer it at the end, and feel free to join via audio to share your thoughts as well. We'll be right here. And so as part of today's agenda, what we're going to do is first talk about design for additive manufacturing workflows. How are organizations thinking about this for vertically integrated distribution networks, or how are they thinking about it with their third-party supplier vendor network? As well, depending on the different stages of additive manufacturing, how are they thinking about structuring their organization? Then on the production planning component, what are the different key areas you should think about when you're planning for production so that you can truly optimize and scale out your additive manufacturing operations? Finally, how are organizations building the right foundation to schedule their parts and to then have the ability to optimize their production manufacturing day-to-day activities? And finally, we'll cover a couple of key metrics that organizations are looking at so that they could truly align themselves to meet the organization's goals, whether it be driving innovation to enhancing the bottom line to have a healthy profit margin. So let's get to it. So here at Link3D, we work with over 200, 300 OEMs to help them figure out their additive manufacturing supply chains. And it's really exciting because we get to meet folks from so many different walks of additive manufacturing, from research and development phase, building phase, and scaling phase. And each stage brings in its own unique set of requirements. So during the R&D phase, a lot of folks are looking to outsource to service bureaus to find use cases, start working with machine companies to figure out what is the correct AM technology for their organization. And then as they find these use cases, a lot of organizations will now invest in additive manufacturing, or sadly not. But for those that do continue this journey with us, a lot of them are either thinking about, hey, will I be scaling up my distributed manufacturing network with certified vendors, or will I be investing in a center of excellence, start building out facilities, and scale out machine sales? And so some of them will move on and go towards scaling when they find that there are use cases that are beyond prototyping, beyond tooling and fixtures, and more towards end-use parts, producing parts that will be in the market tomorrow. And so what could they be developing a strategy with their certified vendors and building out the right risk management strategies to ensure that their incentives are aligned with yours, and also that they will be able to meet your output requirements and meet your traceability requirements as well for repeatability purposes. And for those that decide to build in-house for your vertically integrated setup, then perhaps you need to think about how you're going to scale this out geographically. How are you going to bring in more talent into your network so that you can truly drive innovation, whether it's through product innovation or driving supply chain costs down. So what's really interesting is, depending on where you are in your additive manufacturing journey, what we found is a lot of companies, especially in the R&D phase, are looking at design softwares. But then once you start building and scaling, it's really hard to scale out your additive manufacturing production systems with just SharePoint, Jira, Excel sheets, emails, face-to-face meetings. A lot of organizations are now moving from 5 people from managing orders and processing orders to 200, and then in the future, hopefully 3,000 to 5,000 engineers who will be processing orders for additive manufacturing and really take advantage of the benefits here. And so as you scale and grow, so will your sophistication regarding the types of systems you want to introduce to your company to drive product innovation. And so what we found at Link3D is, as organizations grow, they're looking at how can I bring in more data points into the conversation? How can I integrate, an Autodesk or materialized products or other types of build prep, physics-based simulation, production process simulation into your additive manufacturing ecosystem, so then you can then run more analytics, take this business intelligence data and really drive it into some actionable insight across your design cycle and also your production cycle as well. So starting to think about the data strategy behind your supply chain is super important to push for your digital strategy and push for innovation. And so here, what we found is, as organizations are designing their end-to-end workflows, a lot of folks in the research and development phase are looking for a simple solution, something that can help them process orders, understand their cost, and figure out if there's a good business case for producing 3D printed parts. And then need a simple status update to manage production planning, scheduling, post-processing, because the current setup is pretty simple. Or perhaps you're outsourcing to other vendors who are taking care of this manufacturing overhead. And for those that are building, now that you have 5, 6 machines, maybe you're moving towards your 20th machine, you're now having some struggle. How do you manage production across your facility or multiple facilities? How do you maximize your production? How do you make sure your quality output is up to standards? And then how do you also manage downstream manufacturing processes to keep track of everything that happens downstream? And so here, organizations are starting to look at introducing production planning tools, machine scheduling, but with this level of investment, it also means that they're starting to position themselves to scale. So what we've seen shortly after is, once organizations have started introducing scheduling systems to help automate workflows, hopefully connect their machines to their machine scheduling to centralize day-to-day management activities, they are now looking at, hey, how can I bring in workflow automation across downstream manufacturing processes? How can I get everything done from post-processing, finishing, labeling, all the way down to delivery in one system, and have the data to track all of this so that I can then run my business more efficiently. And so what we've done here at Link3D is we help organizations figure out, what is the digital strategy behind vertically integrated strategies or distributed manufacturing strategies. So I'm sure you guys have all gone through this practice. Should I build in-house or should I outsource? And so we all know that it requires a lot of capital expenditure when you have all of your machines. You want to develop and protect your IP, and you want to have higher control over your end products. But what's really a big struggle that we see a lot of OEMs is, how do I drive more internal sales? How do I get more of my business units taking advantage of additive manufacturing? Do I have enough demand internally to help support my internal supply? And so this also comes down to access to talent. Do I have the right folks in place that can help me make use of this technology? We hear so many times OEMs have machines that are just sitting around the corner and not working. And that's really sad, because a lot of folks work so hard on developing this technology. You went through a huge procurement cycle to bring this in, and then now it's not being utilized. And on top of that, the administrative overhead to managing all these operations, from ordering, production planning, scheduling, all the way down to delivery. But what's great about a distributed manufacturing supply chain is that you don't have to handle all of these questions. It's great because you can save some costs for initial development. You can have access to great talent pool that can help you drive innovation, but also you could now, optimize your production capacity if you don't have the right equipment in place to produce the parts you want to produce. But of course, we all know lack of control, inability to really track and measure quality, and being able to communicate clearly with your partners is sometimes of a struggle. But if you developed a strong relationship, this might be an interesting way to go for your business. And so as companies are, as companies are moving forward, they're now thinking about how do I manage all of this influx of orders? Whether you are an OEM that's managing your production, or if you are a service bureau that is managing your customer demand. And so Link3D, we've developed a couple of production planning tools that help you truly optimize your production planning process. A lot of companies will take all of these files, process it with their software systems, and then use Excel sheets to manage when parts will be scheduled and how many parts will be scheduled per build, and use a bunch of Excel models to bring this together potentially. And so what we've done is develop single batching and multiple batching systems so that you could easily see how many parts could fit in your build, so that you can now prepare for production today, tomorrow, and in the future. So more on the why, when should we do single batching versus batch building, and maybe you know this as well, is that you want to optimize for quality output for single batching, and you want to be able to manage all the inputs to hopefully achieve repeatability through this process. And obviously when you're batch building, the use cases we've seen often is for prototypes, show pieces, or even tools, jigs, and fixtures where quality might not be as important. And so maximizing machine capacity is super vital so that each ounce of time is best used. Hey, Shane, do you want to share some of the experiences that you've seen from automotive and aerospace companies?
Yeah, so I think to just dovetail off of what Janet was saying, and I'm pretty sure everyone on this line looking at the attendees has a very good understanding of single and multiple batching, and why or why not this may be a great use case. But I think just as far as our technology goes, what's quite interesting is we have recently been introducing something called dynamic production planning and dynamic machine scheduling. So essentially, depending on the rules that you input into the Link3D system and configuration, the system is smart enough that it can, based on materials or lead times or the type of work order that you have, meaning prototype or it's a jig or a fixture or series production, the system uses an applied physics-based model along with a host of other types of science-based technology to batch and schedule your work order request automatically. So, some people are quite sophisticated and really have, packing and nesting and systems in place, and others aren't. So what we've seen, for example, is, trying to use some type of like Dropbox or SharePoint to collect all the work orders, or email, or whatever the case may be, and then manually having to upload those files into some type of build preparation software one by one, figure out what should be built together, what shouldn't be built together, what lead times do they have to meet, so which part or work orders do they have to leave out of that build, for example. So, I think having a a rule-based engine that can look at, the delivery dates, the types of post-processing that parts has to go to, and also factoring that into the build time and production time simulations is really helping customers achieve faster throughput. And, our goal is to help ensure that whether you're an OEM or a service bureau, that your parts are delivered to your customer, beforehand or on time. So really understanding, this type of strategy can be arduous. So having a system that can automatically do it for you with rule-based engines and different types of physics-based simulations really gives you a better insight into will you make your lead time, how long will your machines be busy, how much material will you use, so on and so forth. So those are just some of the high-level use cases which I would assume everyone on this line has gone through before, or is thinking about as they scale up and start building more and more parts for their customers.
Thanks, Shane.
You're welcome, Janet.
And so, and like once you plan your production, one thing you want to do also in tandem is work plan management. What happens after 3D printing production, because life after that still exists. And so what we found is organizations are either taking a technology-focused approach or use case approach for developing their work plans to figure out what are the steps that must be taken or in order for you to ensure your part can be delivered. And so one thing that we've recently introduced as well is questionnaires that will help organizations start introducing more total quality management systems to now trace and track all the data points related to those post-processing activities, and then run reports and truly better understand what's going on during your downstream manufacturing process. What's also really interesting is how do you want to take a digital approach for workstation management? Do you want to do it by location or different cells within your factory floor, or do you want to do it by function? And being able to have a better view to manage your workforce is sometimes what you want to take into consideration when developing these strategies. What we have also built into the workstation management is for each card, timestamping, document control, centralized communication, yield management, automated workflow. So each activity is taking place one after the other in tandem as long as things are getting completed. But depending on your business, if things fail, what happens? Do you send everything back to the production queue, or does your company want to have it backtracked back to a previous work plan item? These are questions that organizations must think when they come to strategize what is the quality output that you guys are hoping to achieve, and how do you want to deliver your products to your customers as well. And so moving forward, trying to be mindful of time so we can show you a little bit of our product demonstration here, is these are 3 fundamental areas that you must look into when you want to build a strong foundation to optimize machine scheduling. A lot of organizations have systems that are modular or standalone products to manage their scheduling, or they do everything through Excel, and even sometimes we've seen whiteboard. But what if you're able to connect your order management system with scheduling? What if you're able to connect post-processing management system or additive manufacturing execution systems with machine scheduling? That way, you don't have to re-input all the data from the very beginning 2 to 3 times. This is a lot of time saving, but also a lot of administrative overhead costs that could be minimized, and reduction of data entry errors as well, which we've seen a lot of times could cost lots of money.
Yeah, and I think one other thing that's quite important here is, obviously pre-production and post-production having failure logics or corner case logics. So at least in my experience, because I work with our largest OEMs, it's all good to have a system that is configured or set up for successful builds or successful downstream processes. But we all know, coming from this space, that we have a lot of failures, whether it's through the print or it's through post-processing or the quality control aspect of the downstream. So having failure logics to be able to document, hey, why did this part fail, right? Was it a machine error? Was it a layer thickness? Was it, too much heat treatment? It didn't pass quality inspection for specific porosity, whatever the case may be. One, being able to document this, and then also having a failure logic that will reroute it into the production queue again, so that you don't forget to rebuild it, or you can batch it in with with a job that may have extra capacity depending on your functional use case is quite important. And we learned that by working with some customers, trying to really understand why things fail, how things fail, and how they currently handle their failure logic. And we already had automation software and all these tools built out, so it was quite easy and a no-brainer for us to also build in failure logic to help you track and understand and give you reports on different aspects of the part life's failure as well.
Yeah, and by having all those data points connected, now you can also improve your operational insight. So a lot of organizations currently today can't see what is your machine and material utilization rates across the board. A lot of this data is located in your proprietary machine software, or perhaps you're manually recording this. And so by having this information and also information about the demand of your services, you can also drive more business direction to hone in on who the right user groups are in your OEMs, or who are the right customers are for your service bureau. And then also having timely data across the workflow processes will help operations managers, application engineers, even sales representatives or account managers to now see where are the bottlenecks. Which areas are taking a long time for processing orders? Is it quoting? Is it blocked on production? Is it machine scheduling? And then we can now dive deeper and figure out, hey, is it because of certain technologies or materials, or is it a lack of skill set, or is it a technology error? Basically, you can start really drilling down and figuring out how you can optimize your operations for any purpose within your business. And to add a cherry on top, connected systems, right? If you have machine connectivity to your printers, then you're going to be able to automate data collection, report generation, which can save a lot of time. A lot of companies today have so much data, but they don't even know what to do with it. So having a system that could bring it all together and then translate this business intelligence data into actionable insight is key. As well as agnostic software connectivity, as mentioned in the earlier stage, so that you can now bring in data, design data into the spectrum, and then truly understand how you could control your inputs and outputs better to reach repeatability goals. And so by having all these three foundations, we believe that your organization can start taking advantage of intelligent scheduling system, and which can help your entire organization save a lot of time, have more clarity about your operations, and then truly take advantage of additive manufacturing benefits for Industry 4.0. And so now we'd love to show you a little bit, with the remaining time, a little bit about what we're up to at Link3D. That way you can have a better understanding that, this is not just theory, this is actually reality. So let's do this. All right. So let's say, for example, you received an order. We're not going to go through this process flow. We're going to focus more on, hey, we're a lab technician, or we are an application engineer at the company, and we have now received orders. What often happens is companies will now have to reconfirm what will take place for production, as you can see over here. This will be made on an EOS machine using Inconel 718. And these are the different post-processing requirements needed. And so as an application engineer or a lab technician, or whoever I am at your organization, I will now also put in other types of activities that must take place in order for me to ship the product. So I'm going to add other downstream manufacturing processes like boxing, assembly, and dimensional reporting that will be needed in order for me to complete this order. So I click save and I update the order. Now, what's really important next is, ordering and sequencing what will take place for the downstream manufacturing process during the planning stage. This can help save time and then introduce workflow automation. So let's say, for example, we want to first depowder, remove supports, put it in the heat furnace. I'm going to assemble it and do some dimensional reporting for QC, and then box it and ship it. So once I'm done, I save it, see my part order, and then I will then figure out how I want to schedule my part to production. So Paul, just to answer your quick question here, is MES connected to any ERP system? Yes, it is, and we will touch base on that afterwards. And so once you're ready for scheduling, you can see from an end-to-end view that all the orders are connected to your production scheduling system, and then also to your work center, which houses all the post-processing activities. So what you want to do is figure out, hey, what is in my queue today, and what can I schedule to make sure that I deliver on time? So I can see that EOS machines are available past February 7th. I've got a lot of downtime that have been scheduled, as you can see over here, for many use cases, whether it's a material switchover, maintenance, machine operator time, which could be a soft schedule or could be a hard schedule. So it really depends on how you want to optimize your scheduling. And also the fact that I can easily, from my order submission, once an order has been approved, place parts to my schedule and optimize that. So I can see I have orders here, and depending on the technology, I can also batch orders. So let's say, for example, I can batch these two parts together. If I have a batching strategy in place, I can see over here, this part used to be a total of 2. It means that it has been produced at least once before, and it probably did a partial completion or partial failure. And now it has returned back into queue. And this part must be completed on an M290. So I can see over here, you know, the M290, there's availability as of February 8th. So let's schedule this. And so
this is when you're using the system more with semi-automation. I think Janet for time is skipping over the build planning full automation because we only have 0 minutes left.
Yeah.
So this is more of just showing you how you can use the system manually, and as you grow more comfortable with it, you can introduce full automation into it.
Yeah. So you can see this already has a built-in system that will tell you when parts are not available, machines are not available. And so if I wanted to, I can schedule it for next week and basically have it ready. Yep.
The machine's full.
Oh, the machine's full. Let me just double check my schedule. Sorry about that. Yeah, so once you process your order, what's really interesting next is if your system is connected with your machines, then when it's in production, the system can automatically update that it is now in progress. And if there were any failures, let's say, you can now record how many parts were completed, if they all failed, what were the failure reasons, was it a build prep issue, hardware issue, part quality issue, process issue, and have that in one system. But if you have completed the order, then you can see, hey, you've collected it. You can identify who was the application engineer that was part of the team that produced the order. And you can also upload any kind of additional files, support files, and also mark it. We want to provide a more structured way to manage your data. That way you can have a better understanding with reporting tools about your organization and the current processes in place. So you can also see over here when orders are completed or partially completed, you can see all of the status updates. So you can see over here, this pails part has been completed 5/5. But let's say if a part order failed, as you can see over here, let me bring it up. Oops. For example, this turbine that failed, I can now see from this line item here, from this multi-part order, that these many orders were part of this build ID. There was a failure here, and for each of these orders, we're building one, and there's so many parts that are remaining to be completed. And so once orders have moved through the production scheduling system, now you want to manage what happens in the downstream manufacturing process. These are typically handled by different folks. And so right when you arrive, you'll see as a post-processing technician, what parts do I need to process today?
Yep. Yeah, and what's interesting, here you can see a Kanban view, which may be more of a general manager, head of facility, or head of post-production type screen. So what we've seen, is companies that are this far, they have either an iPhone or an iPad or a CPU within that workstation, and you can easily filter it out and sorry, Janet, go ahead. Easily figure out, hey, I work in the heat treatment cell. What parts are coming, what parts have arrived, which ones have completed, do I need to work on today? So there's layers of filtering that Janet will show you here that you could see. So these are all of the work cells within my org. So someone could pop in, put the filters on for their work center, and just have a very simple view of what production items they need to work on for that day or this week. And this captures all of the data, and it captures all of the rest of the downstream processes that must need to be complete. This is kind of hard to demo in 2 minutes, but I think Janet just wants to give you a high-level overview of the UI, UX, and how some of these things work.
And if you're interested in learning more, we can always show this to you and cater this to how your operation runs. But basically, there's a data component to managing all the total quality management questions that you might have here. You can centralize communication. You could also update where it is in your manufacturing, post-processing manufacturing processes. You can also assign tasks to other folks that are in this workstation and identify how many parts have been completed, how many have failed. And so this is great and all, but having collected all this data, how do I use it for my production purposes? And so over here, Link3D also has an integrated data analytics solution that can help you truly understand, what is your demand? How many orders do you have per month? What is the current status? What is the primary use case that will drive business decisions? But also on a machine utilization level, how many jobs are running that are completed or are in progress? How much time have I spent on each equipment? Am I truly maximizing its build? Am I able to understand the part volume distribution? Do I need to buy a bigger machine or smaller machines to maximize my capabilities? Or do I need to look at how many parts are printed by month to really understand what's driving business innovation, and if I need to purchase more machines or outsource to partnered service bureaus? And also, how often are my machines down? Am I getting the service level based off of the agreement with my machine partner? And can I share with them, the struggles and my pains so that they can truly find a way to better enhance my manufacturing process and capabilities? And finally, material consumption. These are just like one of the 40 off-the-shelf charts and metrics that we help you track. But as part of Link3D, if you have your certain KPIs that you want to track, we'll figure out, is there a data strategy behind it? And then are we already collecting it, and how can we bring this to light for you in real time? And so that pretty much summarizes our little demonstration today and about how we are helping organizations with their additive manufacturing strategy. So we'd love to now open the floor for questions and have Shane share some of his experiences as well. So let's begin. Ian, thanks for your question. Is Link3D a cloud-based service, or can it be installed into my organization's intranet?
Hi, Ian. That's a good question. So it can actually be deployed in 3 various scenarios. So you have Link3D's private cloud. We have experience installing the system in org's private cloud as well, or it can be directly on premise. So to answer your question, we actually have 3 ways of deploying the system. Yeah.
Great, thank you. Hope that answers your question, Ian. Lee has another question. Do all operations have to be in-house, or can you manage outside vendors from your system as well? Example, heat treatment of parts.
Yeah, no, that's a good question. So I think Janet mentioned in the beginning that, so Link3D acts as a network orchestrator. So we have a host of baseline technologies based on what you are most interested in using, or what's going to give you the most operational insight. You can use modular by modular. The other thing that's quite unique is you can actually extend an API invitation to your contract manufacturers or specific post-production houses. So once the order, let's say, has been built internally, you can actually route that order. So if you need the heat treatment, for example, or some type of white light testing for quality control, whatever the case may be, you can actually route the orders and the information to your approved contract manufacturer. So you have the ability to essentially route orders internally through multiple facilities, or externally if you add them into the system.
Great, thank you. Jens, how do you handle batching with various nesting strategies? And as a second question, did you build any nesting strategies in-house, or are you partnered with the likes of Materialize or Assemblix?
Jens, that's a good question. So let me answer first. So we actually have developed TrueShape and TrueShape 3D and TrueShape 2D nesting. So for powder-based polymer prints, you can use TrueShape nesting that we have developed in-house. You can also use our TrueShape 2D nesting to figure out, let's say, more on the powder bed metal side, your packing strategy, build time estimations, material estimations, etc. So we even take into account the support structure generation. Now we don't physically show you the support generation because we aren't trying to step on the toes of the likes of Materialize or Assemblix or GrabCAD or any other software systems that truly give you the support generation. That's a very physics-based application for something that we do not focus on yet to date. So that, to answer your first question, so nesting is done in-house. And how do you handle batching with various nesting strategies? So that's a good question. So we have many different strategies. So, very basic, like optimal Z, is one way as an example to nest, but we also allow you to manually orientate the parts. So different types of work orders, you can actually control the rotation, so the X, Y, Z. So it really depends on how you want to use the system and what you're using it for. So if you're using auto quoting, you may not care as much. You just want to get your production cost out as quick as possible. Maybe you will play with some of the different nesting strategies to speed up or slow down the build for quality control or whatever the case may be. But you also have the ability to manually control the rotation of work order requests within your single or multiple build. Sorry, I went on for a long time.
Thanks. Anonymous attendee, is it possible to run analysis on post-processing operations to find bottlenecks in your current process?
Yeah. So basically, all of the downstream processes are connected to our analytics module. So depending on what it is you're looking to track, if there's a data strategy behind it, it can sync to the analytics module, which you saw. And I'll give you, there is a large aeronautics company that we are working with that has a rule set that not one part can remain in one post-production cell for over 6 hours. And that's all they care about tracking. They just want to know, hey, this widget was in, painting, or this widget was in polishing, or this, widget was in sandblasting. Did it meet my requirements of under 6 hours? So you can even set up rules and strategies for specific post-production requirements like that. So you have full visibility into reporting and identifying bottlenecks. Anonymous.
Great. Elvira, is there any functionality to monitorize process parameters in real time or record log files from the machines?
Hi, Elvira. Yeah, so if we have connection to your machine, So Link3D is very focused on what we call the big 8 or the big 10. We haven't figured out which one it is yet, but if we have the ability to bilaterally communicate or even communicate with the machine and pull data, we can pull process monitor log files. We can also pull other specific information from the machine, like actual build time, is the machine on, is the machine off, has it failed, has it paused. We can pull out a whole host of different things and attach those reports with that production run, or potentially, again, if there's a data strategy, have it connected to our analytics or metrics dashboard.
Yeah, thank you, Shane.
Yeah.
And just a little thing here is that for every order that is processed, there is a data strategy where you can collect and generate reports seamlessly as well. That way it can help you build use cases. And so Moritz asked, hey, thanks for the presentation. Oh, thanks, Moritz. I would like to know if autocoding does assembly files.
Moritz.
So we can definitely take your question offline, because today we want to focus more on production scheduling and planning. But Moritz, don't worry, we'll reach out to you shortly about this as well. Okay, but yes, there are many different strategies that we have for autocoding today. And anonymous attendee, does your software come all in one, or can you use it modularly? So this will be the last question, since we do have a time stop at 10:45. Shane?
Yep. So one, I recommend reaching out to Link3D sales rep or account executive who can walk you through our modular approach to helping organizations scale for series production or some type of, let's call it mass production or small batch production. So we have a lot of customers, especially on the service bureau side, who want to start with order entry and costing simulations. We have other customers who want order entry, the costing, and the machine scheduling. And we also have other customers, more along the lines of like the Fortune 500s that need the full process automation. So depending on where you are in your journey, I think Janet had showed a slide earlier, we will work with you and consult with you to get you the best solution right out of the gate, and then help you scale up as you start building more parts or start opening more facilities and want to have a connected system for machine scheduling to utilize different types of machines capacities. So it's a very modular approach. I think the point of this webinar series is really our MES product, but I know we'll be launching other webinars based on more specific modules and more specific use cases for why an OEM uses order entry and costing, why a service bureau wants order entry and costing, and how it helps you retain and give the best user experience to your customers, or how you really truly understand true production cost, or why you need to use connected machine scheduling, or why you need these downstream processes. So we'll be launching different webinars based on different scenarios over the 2019.
So thank you everyone for all of your time. We really appreciate you spending the time with us this morning or evening, wherever you are in this world. If you're interested in learning more about order entry, auto quoting, costing, production planning, scheduling, post-processing management, to data analytics and digital strategies to help you support your additive manufacturing vision, please do reach out. We would love to share what we've learned and help you find a way to achieve your goals. So thank you very much. You can reach us at janet@link3d.co or shane@link3d.co, and go on our website and submit a form.